Hello everyone, welcome back to Epistemic X. In our last few videos, we learned how to generate massive amount of random data and mix it all up. But having a million data points is totally useless if you don't know how to access the exact piece of data whatever you need. So today in this video, we will explore how to access the specific elements by using indexing and slicing. Now let's start with indexing. Indexing and slicing operation allow to access, modify, and manipulate data within NumPy arrays with precision and flexibility. So what is indexing? Indexing means accessing individual element or specific subset of element from an array using their position. If we talk about one-dimensional array, elements are accessed by a single index enclosed in a square bracket like this. Now look at this picture. You have a one-dimensional array and each box represents an element. Indexing starts at 0 just like Python list. In positive indexing, counting starts from 0 and moves left to right, or we can say it moves forward direction. And negative index start from right to left direction, or we can say a backward or reverse direction. And the last element counting starts from -1. Multi-dimensional array use tuple of indices to access element like this. And we can access the multiple elements by using slicing but in ordered way, while unordered elements can accessed by the advanced indexing, not basic indexing. Now let's understand with some examples. I have a list and convert in array. Just press enter. Now I want to put the index value within square bracket. Now let's see. This value is showing the fourth element 1, 2, 3 and 4. If I put the negative index value, now let's see, and this value, that means the second last value. Now let's understand with 2D array indexing. In a 2D array indexing, we access element using two index. First for the row index value and second for the column index value. Now look at this picture. This is the 1D array indexing and this is 2D array indexing like a Excel sheet. In a 2D array, positive indexing starts from 0 and moves top to bottom for rows and left to right for columns. Rows are counted from top to bottom starting at 0 and for the column are counted from left to right starting at 0. But in negative indexing, everything works in reverse direction. Rows are counted from bottom to top and columns are counted from right to left. And the counting starts from -1. -1 for rows means last row and -1 for column means last element. Now let's understand with the same example. This is 2D array. Now reshape. To access an element in a 2D array, we use row and column indices. Here, one is the row index and two is the column index. Now let's see the element at this position. So at that position, the value we find is 210. Now let's try negative indexing. I'll use -1 for the row and -3 for the column. Now let's check the final output. Using positive indexing, we accessed the element at row 1 and column 2 and we got 210. Now the question is, can we access the same element using negative indexing? Let's try that. From the bottom, this is the second row. So the row index becomes -2. And from the right side, this is the last column. So the column index -1. So now if I write row index minus 2 and column index minus 1. We again get the same value 210. So this clearly shows that positive and negative indexing are just two different ways to reach the same element. Now let's move from 2D to 3D array indexing. In 3D indexing, we always follow this order: layer index, row index and column index. So we are using the same logic as 2D arrays. Here just one extra dimension, layer index. We are taking the same example we used earlier and just adding a few more values to convert it into a 3D array. Let's understand this step by step. We now use three indices and we are going to reshape this array to 3 and 3. That means 2 represents number of layers, 3 number of rows and another 3 number of columns. Now I am putting index value within square bracket 0, 1, 2. The first index is 0. That means we go to layer 0. Now inside layer 0, second index is 1. So we go to row 1. And the third index is 2. So we go to column 2. And we get the final output 210. Now let's verify using negative indexing. Now we are going to put these values minus 2 and minus 1. This is the same process as positive indexing but reverse direction. Minus 2 represents second last layer and minus 2 second last row 125, 250 and 210 and minus 1 last column. Now the final output is again we get 210. Now let's move on advanced indexing. So far we were accessing one element at a time. But what if we want multiple elements at once? Then we will use advanced indexing, or we can say fancy indexing. We can do this in two ways, using lists and using NumPy arrays. Now first we will use by using list. Now let's understand how it works. First list row index 0, 2 and the second list is column index 1, 2. Now NumPy pairs them 0, 1 and 2, 2. So the final output is here. Now let's do the same thing using NumPy array instead of list. The logic is exactly the same, but now we are using NumPy array. So again we get the same final output. But the important point is here, both index collection must be the same length because NumPy selects elements pairwise. Now let's move to another advanced indexing concept in NumPy, condition-based indexing, which is also called Boolean indexing. So far, we were selecting element using indices. But what if we want to select elements based on a condition? That's where condition-based indexing helps. Now let's take this previous example. Now we apply a condition. Now let's break it down. This gives remainder when divided by 5 and this checks which values are divisible by 5. This creates a Boolean array true or false for each element. Now we use this Boolean array to filter values. And now this is the final output. So where the condition is true, the value is selected. And where it is false, the value is ignored. You can also write it directly in one line. Now let this. So condition-based indexing allows us to filter data based on logic instead of position. Now let's look at a very practical use of condition-based indexing. We can use a condition from one array to filter values from another array. Let's suppose we have a product list and their price array. This is the product list array and this is the price array. Now we apply the condition. Now suppose we want to find product name which values in the array are greater than 25,000. This condition creates a Boolean array like this. Each values tell us whether the condition is satisfied or not. Now here is the interesting part. We apply this condition to filter the product name arrays. Product underscore name, and we apply the condition within a square bracket. And the final output is here. So where the condition is true, the corresponding product name is selected, and where it is false, it is ignored. We can also filter products values using this condition. Now this time we will use pricing array. Product underscore price. The condition is applied within a square bracket, and the final output is here of the particular product price. So with a condition, we can filter multiple arrays. This is very useful in real world data analysis. So today in this video, we learned how to access data using basic indexing and then move to multidimensional arrays including positive and negative indexing, and finally explored advanced and condition-based indexing. If you found this video helpful, hit the like and press the bell icon, subscribe to the channel and share it. If you have any doubt, let me know in the comment section. Thanks for watching. I'll see you in the next video.